Hello and welcome back to Josh Does Math. In this video we're going to be using implicit differentiation to find dy dx. So here is our implicitly defined function right here. And it's implicitly defined because y is just mixed in with your x's and you can't really separate it. Or maybe you could separate it, but in this case you can't separate it, so that's why y has to be mixed in with all of your x's. So our goal is to find dy dx, and although you can't isolate y at the beginning, we can still find dy dx by isolating dy dx later on. But the way this works is you just take the derivative of both sides with respect to x. So I'm going to do that with both sides right here, starting on the left side and starting with this first term here. So that first term, that's going to be the product rule for derivatives. And the product rule says derivative of the first times second plus derivative of second times first. So derivative of first is going to be 4x to the third using the power rule, and then we write second plus derivative of second. That's going to be dy to the third dy times dy dx. I just wrote that using the chain rule, and then I'm multiplying that by my first. So I set this up using the chain rule. Didn't take derivatives yet. I'm just setting it up because I know I'm going to use the chain rule in the next step. Minus. Using the same thing, you can pull that 3 out front, so minus 3 times, and here I go, I'm using the power rule again. Derivative of the first times second plus derivative of the second times first. And this is all equal to 60, but I'm taking derivative of 60, which is 0. Alright, now I have a couple of dy dx's in there, but first I'll just clean up some stuff and distribute, do that sort of thing. So I get 4x to the third, y to the third, plus, this is going to be 3y squared, I just use the power rule here, times x to the fourth, dy dx, minus 3y minus 3x dy dx. And that's equal to 0. So as you can see, I have x's, I have y's, and I have dy dx's. My goal is to find the dy dx's and completely isolate them. So we have dy dx here and here. I'll keep those terms and move everything else to the other side. So I have 3y squared, x to the fourth, dy dx, minus 3x dy dx. And that's going to be equal to 3y minus 4x to the third, y to the third. And now I can pull my dy dx out of the parentheses here. And now I can divide each side by this factor here. And although my derivative involves y's, that's completely okay because there isn't really another way to find your derivative unless you take the derivative implicitly in this case. So this is what my derivative is equal to, and I found it using implicit differentiation. Thanks for watching.